Welcome to the Contagious Code Podcast, where we dive deep into code, learn practical skills, celebrate the beauty of engineering, and eliminate imposter syndrome. I'm Tejas Kumar, and I've been building on the web for over 20 years at places like Vercel, Spotify, Zeta, and more. Today, my guest is the one and only Mark Erikson. Mark Erikson is the maintainer of Redux and RTK Toolkit. Mark is also an employee at Replay.io, an engineer where he works on building the best debugging experience they can through actual replay of browser events. And then that is a replay not of what users click on, but instead of system calls that this browser records and then transports over secure protocol, ultimately giving developers reproductions of issues that are far beyond just videos. They look like videos, but they actually capture actual system calls and allow you to time travel debug like never before. With Replay, you can even, for example, add a console.log, so a print statement, after the fact, before something happens, before a bug happens. It's very strange, and it is truly time travel debugging. We go in depth in all of these topics today. We talk about Replay, the protocol that powers it, the backend, the front end, and everything in between. I'd like to offer all of this information to you at zero cost, and the way we can do that is through sponsors. So let's take a moment to thank them, and then we'll dive into the discussion. The Contagious Code Podcast is partnered with Code Crafters. Code Crafters has a really cool way of teaching you how to level up your coding skills by having you implement things like Git, Docker, Redux, etc. from scratch in a programming language you know. In so doing, it solidifies your understanding of the programming language, but also the underlying mechanisms of these popular tools that we use every day. If you want to take advantage of our partnership, you get 40% off. And you can do that by signing up using the link in the show notes. That's tej.as/codecrafters. The Contagious Code Podcast is also partnered with That Conference. They do a conference twice a year, once in Wisconsin, once in Texas, and we give away free tickets. So if you want to win a free ticket to the most closest That Conference that's coming up, share this episode on social media, say you want to win the ticket, and you'll enter a raffle to get one. Finally, the Contagious Code Podcast is sponsored by Stately.ai. Stately is the best way to reason about the way state flows and changes through your application. They have a visualizer where you can model this through finite state machines, and then you can export them to JSON where the states and their transitions already exist, and you just fill in the business logic of how the transitions happen. If you'd like to give that a try, go to Stately.ai. Thanks for sticking around, and now for my discussion with Mark Erikson. Mark Erikson, the great Mark Erikson. It's such a pleasure to have you on the podcast. I mean, I think it's no secret. I've been a fan. I am a fan. I will be a fan. From Redux to Replay to all of it. Thanks so much for coming on the podcast.
Thank you. We've had a lot of great conversations in person over the last couple of years, and I'm really looking forward to this one.
Yeah, thanks. Now, I feel like you don't need an introduction. Your software is in use at so many places on the web. There's people who they just see the name Mark Erikson and they go like, oh, I need to listen to that. But we do want to be accessible and cater to everybody, and that includes some people who may not have heard of you. So with that, could you give us a little bit of an introduction? By us, I mean the listeners. I don't need any. An introduction to yourself and where you've been, what you're up to, and what you're excited about these days.
Sure. So my name is Mark Erikson. I currently work at Replay.io, where we're building a time-traveling debugger for JavaScript, and we will talk about that in a lot of depth shortly. But outside of that, most people know me for one of two things, either as the guy who does Redux stuff or the guy with the Simpsons avatar.
I was gonna say, I'm looking at you here, and for those following on video, I'm surprised you're not the Simpsons avatar. I'm just joking. It's I do. If we have time towards the end, I'd love to even hear about where that avatar comes from. But that's not the focus here. So we'll get to that. Okay. So Replay.io, time travel debugger. That's front of mind. I assume you're coming from work, or this is somewhere in your work time or around it. So
starting the workday in my time zone. Normally, I would just be getting ready to come online about this point. So still working on the waking up part. The coffee is still sinking in, but we're good to go.
This is so cool. He gives me the best part of his day. I'm a firm believer that the morning is the best part of our day. After coffee, of course, after we're fully awake, because we're fresh. And so I appreciate you coming on the podcast and recording this with me as your first order of business. Okay, Replay.io, time travel debugger. let's dive in. I've used Replay. I've done some work with Replay in a consulting fashion. I'm a huge fan. So why don't I lay out what Replay is, how it works, and then you can correct me where I'm wrong. I think this format works really
Sure,
well because I'll
sure.
probably get something wrong. Okay, so Replay is a browser that you use to go to a bug that you found in some type of web application, some type of specifically React application. You hit record. This browser has a record button. So you hit record, you literally play the bug while it's being recorded, and you hit stop when it's done. And then you get a URL to what looks like a video, but it's not a video. It's an actual replay of the JavaScript event loop that was recorded at the time. And you intercept all the events, including the React render cycle. You also capture sources, so like the source code, the JavaScript bundles, etc., and upload all of that to Replay. And I guess the detailed discussion we'll have is how all of that fits together. And then what the end user gets is like an HTTP link to this thing that looks like a video, but it's all of this, and they can send that then to engineering teams where context is king. You get way more context than just a video. How far is that from the value prop of Replay? And then let's go into the details.
Pretty close. The couple immediate caveats I would put with that description. Number one, because Replay, the recording browser captures everything that ran in the page. So it does not matter whether the app is built with React or Angular or Vue or jQuery or Vanilla.js or whatever. If it was JavaScript running in the browser, we captured all of it. We do have some specializations and specific integrations to try to debug React apps specifically, but you could absolutely use it to debug literally anything that ran in the browser. And the other slight caveat is that when you're looking at that link that takes you to the debugger, you do see the video view of what was going on in the page, but what you're actually working with is basically the Firefox DevTools as an app in the browser, because our actual code base started as a literal copy paste of the entire Firefox DevTools code base. Now, we have since rewritten effectively every line of code, but that is actually how our client application started.
So the replay debugger application, the one where you view the replay, not record the replay. And I think it's important to capture these are two distinct experiences. There's a recording experience, there's a playback experience, or a debugging experience. The debugger, you say it's a copy and paste of the Firefox DevTools, but it's a big React app. Now, that begs the question, were the Firefox DevTools a big React app?
They still are. Yeah, I mean, if you go to the Mozilla sources and you look at the DevTools folder, it is literally a React Redux application. Now, the caveat is that I don't know what the old version of the Firefox DevTools was originally written in, but they were rewritten in React and Redux around 2015, 2016, which means that even today, the Firefox DevTools source code is still a 2015, 2016 era React Redux application. It is written in plain JavaScript. It is using Connect everywhere. It is using higher order components. There are very few function components, very little use of like the use selector hook or anything like that. And so when I came on board, fun fact, like today is actually literally my 2-year anniversary at Replay. I started March 14th, 2022. So when I came on board at Replay, our code base was probably about 140,000 lines of code on the client side, I think. And about 120,000 lines of that were the original copy pasted Firefox DevTools code. That was all plain JavaScript, a lot of legacy looking code. The other 20,000 was newer and specific to Replay, and that was things like the library page or the print statement panels, some of the time travel-y aspects. And a lot of my first year at Replay was spent trying to modernize that code base. I did almost all the work to convert it to TypeScript. I modernized a lot of the legacy Redux code. My teammate Brian Vaughn began taking chunks of the UI and rewriting feature after feature to use modern React techniques like suspense and concurrency. And we also went in and deleted a lot of code. There was a lot of code that was, either only relevant for Firefox as the browser, or didn't make sense in a time travel debugger context, like code for the CSS rules panel to edit the rules. Well, you're not doing any editing for a time travel debugger. That's all read only. You're showing what it was. You're not trying to make changes to it. There were also some very, very weird patterns that had been around in the Firefox code, which frankly were very, very hard to deal with. The pattern for data fetching involved a bunch of mutable classes on the client side to fetch you would fetch descriptions of JavaScript values, and then you had these mutable classes that would wrap the plain data and then give you methods for fetching more details or tying things together. Those existed, but that also meant we were putting like mutable class instances in the Redux state, and it was a nightmare. So
Gosh.
We spent basically all of 2022 just trying to modernize the code base. Probably deleted like 40,000 lines of dead code, ripped out chunk after chunk. And so by the end of 2022, we actually had a pretty good foundation for more, like actually starting to build new features. And then Brian in particular has gone in and, finished ripping out and modernizing several other features that were in the UI over the course of the last year.
How does one? There's so much there. First of all, I didn't even know that the Firefox DevTools was a pure JavaScript app.
Yep.
That's a testament. So many people say, hey, you can't build something huge and at scale with React, and these are usually the trendy like Astro, Solid JS, quick type people who go like React's too slow, React's too bad. Wow, browser DevTools are not a small feat, especially if I think of like network waterfall views or the timelines, right? Those are highly dynamic styles of things. And if you're doing especially the network inspector, there's going to be millions of rows appearing instantly in this table as you load a web page. And then you need to think about virtualization and all of that. Absolutely nuts. You talked about the migration effort, and you said you spent all of 2022 doing that. So it took a year. That's what I'm hearing. It took a year to take this thing. And
effectively, yeah.
Wow. There's people listening. I'm one of them who has also occasionally inherited really difficult code bases full of legacy things. I've inherited like require.js style code modules that then needed to be modernized to Webpack and so on. This was back in the days, like when we have to write our own Webpack configs. There was no abstractions like we have today. Anyway, that was a pain. You've done the same. I'm
oh yes, multiple times.
And so the pain, right? And I'm sure a lot of people listening here, if there are a lot of people listening, are going like, oh, I know what that's like. How did you stick to it? How did you find the joy in walking into work every day and having to deal with, oh my gosh, this is a mess. I need to fix it. At some point, does that not become thankless? How do you keep the regular hits of dopamine, for lack of a better expression, going there?
In some ways, the work of doing a conversion process is that hit of dopamine. There were a bunch of different stages. Like I walked in knowing it was a quote legacy React and Redux code base. The client code base is fully open source. You can go look at the repo, you can browse the source, you can see all the PRs that we've done. You could go back in the PR list and see all the PRs that I did in 2022 to help modernize things. And so I walked in knowing what it was like. In fact, like literally one of the first things I did, like my third day on the job, the Firefox code base used a version of the Redux Thunk middleware that was kind of custom. It did the exact same thing, but instead of passing the dispatch and get state methods in as separate arguments to the function, it turned them into an object with both of them together. And that worked, but it was non-standard enough that it would not work with a lot of other Redux code, like, for example, some of the Redux toolkit pieces that expect the standard Thunk middleware to be in place.
Right.
And so, when I walked in, there were probably like 200 some places in the code base that were Thunks using this particular pattern, and I knew that was going to be a blocker for like even introducing Redux toolkit at all. And my initial thought was, okay, like I'm going to take a few weeks and try to get a feel for the code base and figure out what's going on, and then I'll try to get some unit tests in place and eventually try to modernize these things. And my CEO Jason, who you know very well,
Yes.
literally on the third day is like, no, just jump in, like rip out all the thunks and do it all at once. It's like, and so I did. There is a PR that I titled "The Great Thunk Migration of 2022," where I did a whole lot of search and replace for very specific patterns of accessing those fields. And
Was this
I did the whole
or after? Sorry to interrupt you, but I'm curious. Was this before or after you moved the entire TypeScript, the entire code base to TypeScript?
This was before. This is the third day.
Man, that sounds like so much pain.
I know, that's why I was kind of nervous. But then, like with the TypeScript conversion, I will poke at Jason here and point out that he was actually not entirely sure I should be spending all this time converting code to TypeScript. But I fully converted over to a believer in TypeScript in 2019. I've got a post on my blog where I talked about the process of learning TypeScript and dealing with it. And like, I don't ever want to write non-TypeScript code ever again. And so, like as I was going through the Redux logic, I was converting some of the reducer files and some of the actions files over to TypeScript, and then just anytime I was working on, trying to modernize a certain area, I would convert the code to TypeScript. Or, sometimes I would get done with the task at 5 o'clock and I'm like, I'm just going to convert 2 more component files to TypeScript by the time I'm done. And it's something that's very mechanical. Once you get into the habit of it, it's just, okay, open the file, rename to .tsx, go figure out what the props are, write the props interface, names, add some types here.
Can we dig into that with a little bit more detail?
Sure.
Because I feel like there's a lot of people struggling with this. There's this ongoing discourse that JavaScript sucks, TypeScript is good. And that is an opinion I share. That is maybe a hot take. I don't think it's a hot take in 2024. For a number of reasons. And if anyone has an issue with that, leave a comment. I'll make an episode if you want. But there's a lot of people hearing this. I'm also familiar with a lot of folks who are stuck in JavaScript, sort of like you were, and want to make that migration, but feel like stuck. And it sounds like you had a really great system here to go from this, not even like a trivial app with JavaScript, but an entire, like the Firefox DevTools, and slowly migrating that. So I wonder if we can speak to that process and give people a way to migrate their things as well. If it was up to me. I'm stuttering today, Mark, because I'm nervous because you're such a huge deal. Okay. No, but if I inherited this code base, Firefox DevTools, huge code base, and I wanted to convert all this JavaScript to TypeScript, this is what I would do. And you can tell me if this is what you did and where I may be wrong. npm install TypeScript -D, so dev dependency, if it didn't exist. And then I would add npx tsc -init, so do a start, and then I would that's JavaScript is going to just be fine because it's JavaScript, and JavaScript is compatible with TypeScript. So then I would just rename file by file something to .ts, and fight the compiler one by one slowly. Is that what you did? Is there more to it?
Basically, yeah. So backing up a little bit, I have probably spent more time in my career trying to do migrations of one form or another than I have actually getting to build like new features and stuff.
Do you like that?
Sort of. There is some pleasure in taking legacy code and modernizing it, but it's also fun to get to go off and build new things.
Yes.
The app that I worked on for much of my career, well, okay, like going in order, 2011, 2012, I built an app fresh using Google Web Toolkit, which is a Java to JavaScript compiler. 2013, I joined a team that threw an app out the window and built it fresh using nothing but jQuery, which was bad. I spent the second half of the year converting the jQuery into Backbone. We got to build new stuff in Backbone in 2014 and 15. Mid 2015, I realized I was the only one who knew anything about Google Web Toolkit on my team, and I was certainly the only person who had touched that first app's code base. I'd learned JavaScript. I'd learned JavaScript MVC frameworks, so maybe I should convert that code base to JavaScript. But I'd already figured out, like, here's all the pain points with Backbone. That was when I began learning about React in mid 2015. Coincidentally, it was the same time that I began learning about Redux, because it was when Redux came out. By the end of 2015, I had learned all about React and Redux, but I hadn't had a chance to use them yet. 2016, our parent project was kind of on hold, and I got licensed to basically sit around and do the work to rebuild that GWT apps client from scratch using React and Redux and plain JavaScript. Did that for most of 2016. I was maybe like 75, 80% of the way through, and then kind of parent project development resumed. 2017, we were doing more work on the Backbone app, but now I was having to teach people, like, we have 5 different ways to trigger events in this application. Which one are you supposed to use in which situation? Wait a minute, why are we not just using React? So I hacked together something to render React components inside the middle of Backbone views. So they were often taking a Backbone model as their data and rendering. So we were able to start writing some new features with React in the middle of the Backbone.
That sounds cool.
Later on, we actually had some components that were getting some data from Backbone models and manually subscribing to the Redux store simultaneously.
That's like talking to a Hydra, basically, right? You've got multiple heads. Okay.
Mm-hmm. But it worked. So that code base kind of ended up like 50-50 Backbone and React. The team later managed to go back and finish migrating the GWT app and finish that new React and Redux client. 2019, we were supposed to finish migrating the Backbone app to React. I actually set up a brand new React Redux Create React App TypeScript project, and we were kind of proof of concepting like a greenfield version of the app. We had another GWT app that we were going to migrate to React and Redux from scratch. Stupid project shenanigans happened, and that work got canceled at the start of 2020. Later in 2020, I shifted over to a team that had a classic Angular 1 mean app.
Wow.
I'd never worked with Angular anything at all before. So it took me 2 to 3 months to figure out, number one, what is this app even doing? 2, how is the code base structured? 3, how does Angular 1 generally work? And 4, everything is on fire. What do we actually need to do to make any progress? The team was in the middle of trying to rewrite a lot of the back-end stuff, which meant that fields on the front end needed to change. But Angular 1 was all just HTML templates. If you change a field from the REST API, there's nothing that says here's the places on the front end that use it, and there's no type checking, no TypeScript, anything. So we managed to get a stopgap release out the door, spent 2 to 3 months putting out the fires, and then I figured out long-term, I want to migrate this to Next, React, Redux, and TypeScript. And I was able to stand up a Next server behind our Express backend, use iframes to cut holes in the Angular templates, and show pages from Next. And then we could write those from scratch as standard Next TypeScript pages and migrate over one page at a time. And the very last step of the conversion was to swap out the header and the auth and the overlay, and we were left with just the Next app. So
and for sorry to interrupt. And so for interoperability between this like iframe talking to next, you were using like window dot what is it, push message, or you're using
Post
message
message,
passing?
yeah. Yeah,
Right.
there were some
Okay.
places we were doing post message back and forth.
Wow.
So all that, like, and then there was all the replay UI. So all that to say,
Yeah.
like, I've spent a lot of my career doing migrations of one sort or another. So like in the case of converting or really getting TypeScript set up for the rest of Replay's code base, when I came on, we did already have TypeScript set up, and we did already have a portion of the code base in TypeScript. If I was starting from scratch, like you said, install TypeScript, get the basic config file set up, and then I mean, the starting point is like pick one tiny little standalone utility file. You know, that's something with just a couple little basic functions. Rename that to TypeScript, add a couple types, and actually, you know, make sure that compiles and runs. You know,
Right.
and that, you know, just a file converted to TypeScript. And then, you know, to me, it's kind of work your way up from the leaves. You know, start with
Yeah.
the utility files and the things that everything else depends on. Pick some of the files that have, you know, data types, like, you know, maybe some of your API fetching layer or something. And then once you've got some of those, you know, the utilities and the data types converted to TypeScript, then you can actually go start tackling, you know, like a lot of the UI layer, or, you know, certainly if you got Redux in the app, you know, go convert your reducers to TypeScript as soon as possible.
Yeah.
And work your way from there.
This is so good. I appreciate going into some detail there, because a lot of people, as I mentioned, struggle with this, and I think you're demystifying a lot of it. I especially appreciate the fact that you describe what I'm hearing is like go after the low hanging fruit. Like if there's small things and then data types and then reducers. Thank you for that. So okay, bring it back to Replay. So y'all inherited this Firefox DevTools Debugger UI. There was a lot of migration that happened over the course of a year to modernize it and so on. I have to ask the question. So this sounds like a fork of the Firefox DevTools that you then went ham on and fixed. Was there a desire and effort to potentially contribute back some of that modernization to the Firefox DevTools? Did y'all end up opening pull requests and helping out the?
No, I mean, our UI started as a copy paste fork because our founders originally worked on the Firefox DevTools. That's where they came up with the first prototypes of the Replay technology. They were building it into a debugger, and the debugger was Firefox itself. So when they spun off to start the Replay company, they copy pasted the UI. It's open source, and went from there. But you know, like I was saying, the needs of the UI have changed a lot, and we were really trying to, you know, modernize things. Could some of the concepts be contributed back? Yeah, but the data model and the needs of the time travel debugger have diverged enough that it would be kind of hard to directly contribute back a lot of that code.
Okay, this actually prompts another question, and this is probably my last question, and then we'll move to more of the nitty-gritty about Replay itself, specifically the way data flows between the recorder and the debugger and so on and so forth. But I have to ask this before. You mentioned modernizing this thing, and maybe the modernizations aren't applicable to Firefox DevTools because of the needs of the data model and so on have changed. There's an enormous amount of pressure among developers, including myself, to modernize our things. Now, my website is I believe it's Next.js 12. And even like it started as a Next.js 9 site, and it became 12 because Timer from Vercel, he's a good friend. Around the time they came out with ISR, that is incremental static regeneration, they wanted to show the community its power. So I wake up one morning and I find a pull request on my website from the Vercel team, from Timer, and he's just like, bro, I just completely upgraded your website to the latest and greatest Next.js 12. Is this good? If it's good, enjoy. And you know, I saw ISR and I was like, what is this? And we had a really nice long discussion about ISR and its value. And I thought, awesome, let's do it. And that's how I modernized. Somebody else modernized for me, and it was great. I do feel now that my site is, you know, I think it's Next.js 12 and we're at Next.js 14 with server components and all of this like good stuff. that's allegedly good. I don't really know how good it is. That's probably a different discussion. I feel a pressure to modernize my thing, and I feel like a lot of listeners feel a pressure to always be on the latest and greatest, but that just may not be relevant. You may not have to be on the latest and greatest. For example, I bet there's people using the Firefox DevTools today, millions of them across the world, and it may not be React 18 with use transition and all of this, and that's fine. It serves its purpose. So as sort of a way to close out the historical replay section and move to the next one, I'm curious if you could speak to that. Like, one, the pressure of modernizing, and two, the value of modernizing. Is it worth it? When is it not worth it? And so on.
Yeah. There's a lot of points that we could hit here. One of the great things about software development today is the availability of open source packages and package registries and managers, and you have millions of Lego blocks at your fingertips. All you have to do is npm I some package, or Yarn or PNPM or your package manager of choice, and it's available. You just drop it in and you start to use it. The downsides are that for any given problem space, there's dozens of packages that could fit, so you have to spend a whole bunch of time searching through lists and seeing what's available and evaluating all those in terms of, does this even solve the problem that I have? What does the API look like? What's the license? How well maintained is it? How often do updates come out? So you spend all this time evaluating packages. And then as you add more and more dependencies, you end up spending a lot of time trying to take care of updates.
Yes.
And maybe you've got Dependabot set up, and every other week or whatever, you get 30 new pull requests bumping every package to the latest patch release or something. Or there's a lot of work involved in wrangling these dependencies. So we've gained ease of use, we've added extra overhead in trying to manage all these things. And so again, there's all these trade-offs. If you always try to stay up to date, either manually or automatically with just even updating the versions, then hopefully the pain of any one package having a change that does directly affect your code gets lessened and spread out over time. Either there's a patch release that has a bug fix, or maybe a new major version does come out and has some breaking fixes, but because you're dealing with smaller relative size changes more frequently, you can deal with each one kind of in a smaller way. Whereas if you go from next 9 to 12 or 12 to 14 or React Redux 5 to 8 or whatever, the longer you wait, the larger chance there is that something meaningful and tough to deal with has popped up, or multiple small things have added up, and now it's kind of harder to upgrade. So, it's a trade-off. There is no one single answer. I would lean towards something of a middle ground. You probably don't need to update to every single tiny little patch release that comes out. And you don't need to necessarily go modernize and rewrite your code that is there and works just because some newer technique exists. With React, class components still work. With Redux, old style handwritten reducers still work. The fact that there are newer techniques does not mean your code is suddenly invalid, but there are definitely benefits to being able to modernize. With React, function components and hooks, they get rid of some problems. They add some new ones, closures and stale state and all that kind of stuff. But they do add some new capabilities. And also, this is what all the the modern tutorials are teaching. So I'm sure there are a lot of people coming into React today who have never seen a class component and never used one. So you have, if your code base is still largely class components, you might start to have training style issues. With Redux, if you've got a whole bunch of handwritten reducer code and const add underscore to do equals quote add underscore to do, the code's there and it works, but it is very verbose. It can be harder to follow. and it is more prone to things like accidental mutations. And so if you put in the effort to migrate it to Redux Toolkit, then you're going to have less code that you have to maintain. It's going to be easier to work with. It might eliminate certain classes of bugs. So, there is effort involved. Hopefully the goal of the effort is that the code ends up in a better place and it's more maintainable. But also, like, just because it's there, you don't have to rewrite it right this second.
That's so good. I love that because I know a lot of folks who are now, because of all the discourse, thinking, all my components need to be server components. And, we've had this discussion, I think, on Spaces on X, formerly Twitter, where folks are like, oh, I'm using use client. Is it bad? Should I not use client? But the truth of it is all React components are client components until you adopt server components. So there's nothing wrong with that. I really appreciate that you highlight so eloquently that we don't have to use the latest techniques, was the word you use. So valuable. Thank you for that. Okay, let's talk about replay in more detail, because you corrected me at the beginning, which I appreciate. I said it's great for recording bugs and issues in React apps and then debugging them in a time-traveling way. And you said, yes, that's cool for React. It's a specialized case, but replay will, when you hit record, and I believe you put it like this, capture literally everything. And then send it over to the debugger, and then you get a link and so on. You could come in and debug. How does that work? So if, again, I will venture a guess and you correct me. So I open this thing, I hit record, I just navigate, I do whatever I want. There's more than just the JavaScript event loop here. For example, there's the there's page navigations, which includes DNS resolution, HTTP encryption, TCP/IP handshake, all of that layer, and then there's application layer stuff like JavaScript and CSS executing. So if we capture literally everything, my question number one is how, and my question number two is, where does it go? How is it transmitted? And especially, how is it transmitted with like respectable latency? Because if you're recording something and things either arrive out of order or sort of half arrive, then you've lost your bug report. So many questions. I apologize if it's sort of overload, but I'm curious about all of it.
No, those are great questions, and the answer is magic. Okay, so what we actually record is the browser talking to the operating system, and we do have some articles in our docs that go into a lot of these technical details, but operating systems have APIs, and it's things like opening a socket, receiving a network packet, reading a file, making a call to the operating system, random function. And what the founders of Replay figured out is that if you capture all those calls from the browser as a program at the C++ operating system level, talking to the operating system. Yep.
Okay.
Well, I would say lower than the engine. Like, this is below the JavaScript engine itself. If you capture the browser talking to the operating system and you record all those operating system level API calls, you can play those back, and they're inputs to the program. The best example I can give is, think of a tic-tac-toe program that uses a random number generator to decide where the AI is going to move. And if you use a seeded random number generator, you know exactly what quote random numbers it's going to generate. Like, like the next 10 numbers in the sequence. And so based on that plus the logic, you can predict exactly what X's and O's the AI is going to place. It's the same program operating on the same inputs, and therefore produces the same output. That's what Replay is doing, except instead of like a single random number generator, it captured all the inputs to the browser. So every network socket being opened, every packet of JavaScript, every click, every timer, that's what we capture. All that gets written to a binary archive that is basically like, here was a call to the operating system fopen function with the arguments at this time. and here's what came back. And so when you go to debug a replay, I'll actually kind of like walk through the whole stack here. So you go to app.replay.io, you go to the library, you open up a replay. The client side opens up, which is our rewritten Firefox DevTools UI. In the backend, the backend layer creates a session. There is a user opening up this recording. We need to start up a copy of it. And so up in AWS Kubernetes Cloudland, we're going to download the binary archive that contains kind of like the stream of all the operating system calls and their descriptions. And we're going to download a copy of that exact browser build. So if you recorded it with our Firefox for Mac build 2024-01 27, we're going to download that exact build from S3. And then we actually spin up a copy of that browser in headless in the cloud. And we're going to start force feeding it all of the recorded inputs. And we actually kind of like do one initial pass that fast forwards through the recording. And we do a lot of extracting of what we call basic data. So if you think about it, everything that happened in the app is going to be deterministic or repeatable. Like there was an exact list of source files that got downloaded. There was an exact list of console messages that got printed. There was an exact list of network requests that happened. And so if we make one fast forward pass through the recording, we can pre-extract all that data once. And then we never have to re-extract it again in the future because we've cached it and saved it. And so we extract all that basic data the very first time someone opens up the recording. And along the way, we also create a series of memory snapshots at I think it's 5-second intervals. So we actually capture the entire memory space of the browser and we keep diffing it. And then later on, as you are doing the debugging session, if you click on the timeline at 17 seconds, we want to end up with a copy of the browser paused at that exact point in time. So we've got the process running in memory, and we've taken the snapshots along the way. We're going to find the most recent snapshot before the 17-second mark, make another copy of the process running in memory, and then tell that process run ahead, from 15 seconds to 17 seconds. So you end up with this big tree of copies of the process paused at different points in time. And so if you actually then hit the step backwards button, we're going to find another copy of the process that was earlier and run it ahead to 16.99999 seconds instead. If you run step forward, we're going to take the copy that was paused at 17 seconds and tell it to advance forward one instruction or something. So you end up with many, many different copies of the same browser, each paused at a unique instance in time. And now you have a copy of the browser paused, and we've instrumented it so you can start asking it questions like, what's the stack frame or the stack trace at this point in time? What are the variables that are in scope? What are their values? Or even better, go evaluate a random piece of JavaScript at this paused point in time. And so our backend offers up those capabilities as an API. So the backend has an API that we refer to as the replay protocol, and it is modeled after the Chrome DevTools protocol. So there's domains for DOM data and network data and pause data, and you can query it and then it goes and forwards the request to the correct paused browser that you're asking for, and then it returns the data via the backend to the front end. And so our whole debugger UI is built on that protocol. So if when you pause at a certain line, we go and fetch the stack frames so we can show the stack frame panel. We fetched all the list of the console messages up front so we can show those over in the console panel. Every time you pause, we go and fetch information about the DOM structure so that we can show the elements panel. We have downloaded the list of the source files for the recording, and when you click on one of those, we go and fetch the contents of the source file that you're trying to look at. So it's basically a time-traveling backend as a service.
Wow. Thank you for that. This is a great comprehensive overview of the entire stack. I appreciate that. All the way from clicking record, what happens, and walking all the way through to the details there. I have so many follow-up questions here that I'm like itching to get into. Okay, so you mentioned it's during the record phase. I'm calling it that, the record phase. I'm using React language, render, commit phase, whatever. During the record phase, this browser has specialized code at the OS level, so lower than the JS engine, that captures a bunch of inputs. These inputs, as you mentioned, can be keyword events, network sockets opening, timers, a number of other things. Does it capture also data in transit? Because in theory it can, right? Because all of this happens at the network layer of the OS's kernel. So you can like take from the HTTP layer, take a request, and even capture the TCP/IP packets. And they're nothing more than like headers and destinations. I have to assume that would be really cool for like replaying network requests later, but that could also lead to like security issues. So I'm curious if you could speak to the nuance there.
Yeah, I mean, we capture all the network data that went in and out, and that includes everything like potentially cookies and passwords and all that kind of stuff. So we like in our UI, we actually do put in some warnings, like this recording may contain sensitive data from such and such a domain. And so yeah, like there are actually some security concerns. Like if you share a replay where you typed in your password, that's gonna be right there in the recording. Wow. We do have plans to eventually try to do kind of like what LogRocket does, where you can like mark certain areas as sensitive or redacted in some way. We have not gotten to that point yet, but it's a thing we would like to try to add at some point down the road.
Okay, if an enterprise client shows up and is like, "I'll give you $1 million a year," then that probably will make that more compelling to implement.
Potentially, yeah. But like one of the application layer aspects of replay is that replays are always attached to an individual or a team account. Replays are private by default, so you can have the link, but like by default you are the only person who sees it. You always have control over the sharing level, so you can share it with individual emails, and if they log in and then they can access it. You can set them to public so that anyone who has the link can look at it, but you always have control over who gets to see that specifically.
I'm glad you clarified that. I have one more question about the record phase, and then I want to dive in really to the debug phase. The record phase, okay, captures all this stuff from the OS and sends it across the network to some type of backend that stores those binaries. I believe you call them some like big binary blobs of events.
We just refer to that as the recording itself.
Okay, the recording itself. Is that? Can we speak to the schema of that, if there is any, or the data store? Is it just like, so if I venture a naive guess, this is 100% wrong, I can guarantee this, but like my naive brain would be like, it's an array of objects that represent function calls in response to events or events themselves. How far is that from what's actually inside?
I'm not entirely familiar with the format myself, but I think it is basically that. Like I believe from one of the articles that I read a while back, that there's something like, I don't know, like 250 operating system level syscalls that applications can interact with or something. And so, I mean, I would imagine, if I had to guess, and this is somewhere between close and wrong, that it's probably like, I don't know, like, an integer representing the number identifier of the syscall, and then a bunch of, pointers or, string arguments after that kind of a thing.
Yeah. Yeah, I believe, like, for any and this is maybe something that will get some raised eyebrows, but like I believe for any protocol, really what you need is like some headers and some metadata, and that's it. So it sounds exactly like what you're talking about: the numerical reference and then metadata. And it may not be that, but I appreciate you clarifying. Cool. And so all of this is sent over the network and stored somewhere.
Yep.
This answers a question that I get a lot about replay back when I used to do work with replay, and also even to this day. Like if it comes up in conversation, everybody asks me like, hey, why does this have to be a browser? I don't want to download another browser. And
Right.
if I experience a bug in Arc, if I'm using Arc, if I experience a bug in Arc, I want to record it in Arc. So make an extension. And everybody says this, but now I understand that an extension doesn't have the same privileged access as a browser would.
Exactly. In multiple ways. One is that extensions are just JavaScript. They are executing inside the JavaScript engine. Also, extensions are sandboxed, and they only have so many privileges. And this is just not low level enough. So like we truly have forks of both Firefox and Chrome, and both of them have several thousand lines of C++ modifications, as well as like 2,000 to 3,000 lines of JavaScript layer modifications as well. Both the forks are open source. You could actually go to our repos and look at the changes. The kinds of changes that have to be made are, at the C++ level, there's the instrumentation to trap the operating system level syscalls and record that aspect. One problem we've run into is like the browsers are good. They're very complex. They're 15, 20 million lines of C++, but when you're trying to do the replaying aspect, we've spun up the browser instance in the cloud, and now we're trying to run it back through with the same inputs. It doesn't always re-execute the code exactly the same way it did on your machine. And an example of this might be, deep in the guts of Chromium, there could be a hash table. And you've got some browser code that's trying to loop over the hash table's keys and values, but it happens to iterate in a different order than it did during the recording process. And then that's just subtly different enough that the recording starts to diverge, and now bad things happen because it's not replaying the same way. And so, sometimes our engineers have had to go in and rewrite a bunch of Chromium's hash tables so that they use a different base class that always iterates in the exact same order.
Wow.
Or, sometimes there's certain assumptions about repainting the screen where, it tries to defer repainting, but we actually kind of need it to force to repaint so we know exactly what the screen looked like at this point in time.
Yeah.
So there's a lot of very, very low level C++ stuff that happens. And additional to that, the protocol that I described is the public API to talk to our backend to control the browser. But we also then have an almost equivalent form of the protocol that is for our backend talking to the running browser process itself. And so, if I ask, give me a description of this JavaScript variable in a paused browser instance, the backend has to forward that request to the paused browser, which then has to handle it and introspect the value dynamically so it can send back the description. And so a lot of that code is added as JavaScript layer code in the browser, which then talks to the Chrome internals or something to extract the data. So there's a lot of work that has to happen at the browser level to make any of this possible.
Yeah. That's such a good answer. I only now realize that the connection between the backend is not is not one way but duplex.
Mhm.
Because you mentioned the backend then has to talk to the paused browser, which means if it talks to the paused browser, it can also talk to my replay browser here that I'm running on my thing right here,
Mhm.
which opens up a huge Pandora's box in my mind, because then you could you could see that I hit record, and you could even like have like a little, and I hope this doesn't happen, I'm just going to preface, but you could have like a little like clippy AI assistant that go like, I see you're recording a replay, here's 3 reasons why it's caused, or something like that, because the backend can speak to
Mhm.
my browser. Absolutely nuts.
Well,
Anyway, without
the back end doesn't talk to your browser. The recording process is one way. We're capturing the data and transmitting that stream of captured syscalls up to
yeah.
uploaded to S3. So it's in the end, it's a one-way capturing of the recording of here's what happened, and then the replaying process is separate from that.
But if the backend can speak to a frozen replay browser instance, then it can speak to a running one, in theory.
Only a running one that has been spun up inside the backend, not on your machine.
Ah, okay. This is okay, and that there's probably like networking rules and private subnets at play there.
Yeah.
Okay, good. That's what I was confused about. Thank you for clarifying. Okay, so we understand why it's not a Chrome extension and why you need a browser. Let's talk about what happens when you stop recording. That's uploaded, and then when you go open the debugger, you mentioned a replay is downloaded, so that whole binary file, the replay itself, the recording, is downloaded to the user's account or device, or
Well, it's
to the
so we gonna dive into the technical details here. So our back
please.
end is kind of multi-level. There's kind of like
Yes.
a session management layer. So user A is trying to open recording X.
Yes.
There's a second layer that we call dispatchers that controls like kind of like actively managing multiple sessions at once. And then for any given session, we're going to end up kind of like splitting the recording into roughly 30-second chunks for kind of like control and management purposes. And so we're going to spin up a separate service instance called a controller that is responsible for interacting with that 30-second chunk of the recording. So if you've got a 1-minute recording, we're going to spin up 2 controllers for that session. And the dispatcher knows that if a protocol request comes in that interacts with the first 30 seconds, it's going to direct the request to controller A. If it's in, if it's at like 45 seconds, it's going to go to controller B. Each of those controllers, in turn, is responsible for managing the running browser processes, making more copies of them, running them to the specified points in time, and then forwarding the request for information to the correct copy of the paused browser.
Okay. So if I log in to the debugger, find a replay, click on it, or if I click a link from a friend, what's going to happen is this session manager service is going to be like, hey, Tejas trying to open this recording. And so then download it, and not download it to my device, but download it into the backend, it sounds like, into this controller service.
We spin up the services, they download a copy of the browser, they download a copy of the recording data, execute the browser process in the cloud, and then begin feeding it all the recorded data.
Yeah, perfect. You said it's downloaded and then cached. I have a question about caching. Is the caching preemptive, meaning the moment I stop recording, is it then downloaded to the services and cached, or is it cached per session on demand? So like if I try to open something, only then is it downloaded and cached. And by it, I mean the event data. Yeah.
There's several different aspects. So like I said, there's a very, very large portion of the information that is deterministic. So we start with that kind of like raw recording data. There was a network packet or there was a user click. But what happened at runtime is effective, like size-wise, conceptually, it's a lot bigger than that. Like we know that when the browser ran, it rendered the DOM. And I could imagine taking a screenshot every 1 millisecond over a 1-minute recording. That data, like the screenshot itself, is not what was saved, but we could generate a screenshot from the browser having drawn the page. So in essence, we could generate almost like an infinite amount of derived data by taking the raw recording and making the browser replay it, and then asking questions. What was on the screen, or what were the source files, or this other stuff. But a lot of that derived data will always be 100% identical. There was only one list of source files. Every source file had these lines of code. Here are the exact console messages and the timestamps and the contents. So we do want to try to pre-extract a lot of that, what we call basic data, but it does take processing work to do that, because you have to spin up the browser. It takes the EC2 CPU time to run through the recording. That does have a cost. And so, if you've got a test suite that is making 100 recordings every time there's a PR, and you're running, your team is doing, hundreds of PRs a day, that's thousands of recordings. Realistically, people are only going to open up a handful of those recordings.
Yeah.
And so, literally from a cost perspective, it doesn't make sense for us to pre-process every single recording and extract that data ahead of time for every single recording. We want to do it for sure by the time someone opens one up for the first time, or possibly certain signals that people might be interested in this recording. So with our test suites dashboard, we will probably try to do that pre-processing step for a recording of a failed test or something. And we're still working on some of the infrastructure for controlling this. Down the road, maybe we'll offer a dashboard that lets you control what percentage of your test suite recordings get pre-processed. So we enforce that the pre-processing step has to happen before you actually see the debugger screen finish loading, because that way we know we've extracted the key information, and a lot of that gets cached. And so when I ask for certain pieces of info, we can just return the cached data immediately, rather than having to go all the way to a live browser process to ask it for that information. So if I get the list of sources or certain source contents, we've already pre-extracted that. A higher level of the back end can just return it from cache right away.
Yeah. Thank you for that. I feel like you're somehow spying on my notes, because the moment you mentioned the moment you mentioned we might look for cues for when to actually pre-process things eagerly, I literally had it. Just the next thing I wanted to ask you was okay, so if you had failed test suites, would you? And you just said it, so I love that. We're sort of syncing here. Cool. I understand now how it works when you open up the debugger, and then you're in the debugger and you have the list of source files. That's all pre-processed. That's really cool that you mentioned it. Not pre-processed, but processed on demand, depending on the case. I have two interesting questions here. Okay. One is maybe more interesting than the other, at least to me, which is in the replay debugger, you've got the video. You can literally play the video. I'm not sure how that works, so I'd like to tell you what I think and then have you correct me as usual. So you mentioned these memory snapshots in some granularity, let's say 30-second intervals. So for a 2-minute recording, you've got 4 of them, 4 of these snapshots, 4 30-second snapshots. When I replay the recording, is the thing that looks like a video, what is that? Is that the video of a running browser instance in the cloud? But you said you start them up as headless ones. So then does the record phase actually record a video? But it can't be a video because, and here's the thing that really wowed me the first time Jason showed me replay, the thing that looks like a video, I can inspect element and click on elements in the video. So what is that, I guess, is my question.
Okay, so differentiating a couple bits. As I said earlier, what we record is just the raw binary operating system level data. Everything else gets derived from that, one way or the other. Okay. The snapshot bit that I mentioned has to do with the making the copies of the browser process. So, if I want to jump to a certain point in time, we're going to need to make a copy of a paused browser process and then tell the copy to run farther ahead in time. And so the more frequently we have paused snapshots sitting around, the shorter time it is to make a copy and then run it ahead. So like I think we actually do like the memory snapshot thing at like either 5-second or 2-second intervals.
Okay.
So like the responsibility of managing a chunk of the recording is in 30-second intervals, but within that 30 seconds, we may have pre-paused snapshots at like 5-second intervals.
Is this very? I don't know if you do a lot of video editing, but in some video editors, there's this concept of a render cache. Is it like that where?
Probably, yeah.
Okay. Cool. I got you.
So the video is actually just a whole bunch of JPEGs. Like literally, it's a bunch of JPEGs that are being and like this is where our API our protocol comes into play. So during the recording process, the browser internals save timestamp markers that say basically here is a time that the browser painted the screen. So, some JavaScript ran and the DOM got updated and the browser repainted. Mark that. So so that's actually part of what we call the basic data. Like we know exactly the timestamps that the browser painted. We can just extract that list of timestamps once. And so when the debugger session starts up, we ask the protocol, just give me the list of timestamps. There's 5, 10, 1,000 of them, whatever. Yeah. Just give me that list of timestamps. And so if you jump to a specific point in time, or if you click the play button on the timeline and it's just, playing through at 1x speed, we know all the timestamps where a paint occurred. And for every one of those timestamps, we are going to ask the back end, tell me what the screen looked like at that point in time. And the back end is just going to return a JPEG. And we're going to paint that JPEG to a canvas. And so what looks like the video screen is just a JPEG that was painted to a canvas. The end.
This is, sorry, my head's exploding. For those listening, this is absolute nuts. This is nuts, Mark, because I press play like I do in a Cypress test. Mm-hmm. Then Cypress has a video element. I've used Replay pretty extensively. I never knew that that's what was happening.
You're playing in the case of a canvas.
Well, repeatedly at many frames per second. So it's almost like these variable frame rate phone displays where if nothing happens, it doesn't repaint, so to speak.
Yeah.
Absolutely nuts. Dude, this makes that overboard example so much more powerful, because for those who don't know, Replay has this, I don't know if you all still use this app, but they have this sample app called Overboard, where it's an e-commerce shop for hoverboards, fictional one, and it's got this like neon aesthetic, like Blade Runner type vibe. And the thing about this site is it's highly animated. And so it's not your standard, like, if you go on Twitter or something, or X, it's mostly static until some notification shows up. Overboard is the opposite. There's constant movement. And when I look at a replay of Overboard and I hit the play button and it's playing in linear time, I genuinely thought that was a video, a 30 to 60 frame per second video. It turns out it's not. You're just like playing JPEGs for me at that speed.
Exactly.
That's insane. And it's not just playing JPEGs for me at that speed. What you're doing is you're reading from a browser instance, right? You're asking the browser instance, hey, what did the screen look like at this time? And then just playing that JPEG. I'm assuming the browser gives you a JPEG, and you're just playing that JPEG over and over and over again in a loop. Oh my gosh.
The added little tweak there is that the contents of like what the screen looks like at any point in time should also be deterministic. And so I actually did some work recently on our back end to help pre-cache all those JPEGs. We were doing some of that originally, and we were packing them into like a single giant zip archive that had to be downloaded. and we've switched those over to be like individual JPEGs stored in S3. But the idea is during that initial pre-extraction process, we know the timestamps of all the paints, and we can go collect all that data once ahead of time and save them, so that again it's cached, and a higher level of our backend can just return the cached JPEG instead of having to go talk to the live browser process and go a couple levels deeper through the backend.
Yeah. Wow, I had no idea I was interacting with pictures that were animated, which is philosophically what videos are anyway.
Mm-hmm.
The big wow moment, as I mentioned, was my replay is paused. So at this point, I don't have a stream of JPEGs. I have a JPEG, which is rendered inside a canvas, as you mentioned. And when you inspect the Elements tab, you get this little cursor that you can mouse over an element. So you can do this in a browser today, like any browser.
Yep.
You inspect element, and you get this cursor that you can like hover over elements and jump to their respective HTML nodes. You do that in Replay, and that's
Yes.
Do I understand correctly that's a bespoke canvas that can that has the appropriate hover events and things that ties the element panel to the canvas? Is that something that you'll build?
That's where we start to get into actually interacting with the paused browser process. So let me actually kind of walk through like how the element picker works.
Please.
So we're paused at a point in time. We have the video preview, which is a resized JPEG. So maybe it's for simplicity's sake, we'll say it's like 1/4 the size of the original screen that was being shown. So number one, that means that all the mouse coordinates over the canvas need to get shrunk by like 75%. So like pixel 1,1 on the canvas is actually like pixel 4,4 in the original screen or something.
Yeah.
So, first step is we kind of need to do that translation of the mouse coordinates back to what they would have been if you were a real cursor on the original browser screen. And then we use the protocol and we can say, unwinding pieces in my head here. One of our protocol methods that we can send is give me the hit boxes or the client rectangles for every DOM element that existed in the page at that point in time. So there is a DOM, there is a DOM structure. Every element on that screen has some kind of bounding rectangle, and there's all the the Z indexes and the the layers and the stacking aspects involved. So one of our backend API calls is give me a list of every single DOM node and its ID, and for every DOM node, tell me what the bounding rectangle is, and return it in effectively like a pre-sorted Z index type order. And so I think we actually do some work on the client side so that we can say, okay, like let's just iterate over that list, in order, and we know the coordinates, and let's do checks to see if this coordinate is in the rectangle for node 0, the rectangle for node 1, the rectangle for node 2, and because they're pre-sorted for us, we know that the first point in rectangle result that we get will be like the one that was sitting on top of the other 3 DOM nodes that it was overlaid on top of. So at that point, we know the DOM node's ID, and now we can say, hey, element panel, select DOM node 1, 2, 3 at this point in time.
Wow. How long did that take to build? Like you mentioned, you spent an entire year migrating this legacy Firefox DevTools thing or modernizing it, excuse me. This sounds extremely complex. And I feel like it's like Replay, the debugger is at risk of people just underestimating this, because to the untrained eye, it's just a glorified video player. But oh my gosh, the details. How long did that take from start to finish? Do you have any idea? Did you work on that? How many people worked on that?
There's so many answers to it, because the most of the functionality in the front end existed at the time that I joined. Most of it
Okay.
was based on the original Firefox stuff, but possibly repurposed in some way. So like a lot of that stuff was there, but then we've modernized the code. Brian Vaughn has then gone in and rewritten like one feature at a time through most of the code base. I mean, he actually went in and rewrote a lot of the client side portion of the element picker stuff. I mean, the data flow is the same, but the components and how we manage the logic for doing some of that client side piece got rewritten a few months ago.
Wow.
He actually rewrote our React DevTools panel from scratch a few months ago. So
Wow.
we had been using literally the exact same components that are shown in the React DevTools extension. So the tree view and the props hooks panel, etc., which makes sense because it was there and it worked and it's the exact same data format. And also, Brian was the one who wrote those panels for the extension in the first place. And the problem was we had to treat that as kind of a black box. We were just using the package from NPM. And occasionally we ran into some issues where some of the things we wanted or needed to do at like the integration with the rest of the app level, we just couldn't quite do, or it tried to control some data inside of itself, but now you're sort of running into like the controlled component problem, and you're trying to interact with some timing issues at the rest of the app level. So Brian, being Brian, he went in and wrote an entirely new from scratch tree view and an entirely new from scratch props and hooks view that is just components directly in our code base. We have full control over them, and therefore it fits in with the rest of the app. And because it's Brian, it took him 3-4 weeks, maybe.
That sounds like such a 10x engineer move.
Yes.
In my career I've done similar things, not to that degree of excellence for sure, not, but similar. Like where we were using some package and it wasn't quite giving us what we wanted. So I was like, you know what, I'm just going to rewrite this. I think one example of this was many years ago. I was working in a company that relied pretty heavily on Calendly for their operations, but it was too expensive. And they were like, man, we should just like write our own. And this was before the days of cal.com. And so I did, literally, and it just did everything Calendly did, including Google Calendar integrations and stuff. But
nice.
But this was like rage-driven development. I don't know if it was similar for Brian, but anyway, without digressing too much, wow, that is really incredible. So we've touched on elements panel, debugger panel. We've touched on some of the panels, and from the record view to the debugger. One thing that Replay is constantly advertising, and also that was something of a wow moment for me, was the ability to do to add print statements. So console.log something after the thing happened, and after I didn't do the thing. So like somebody records a recording somewhere on the other side of the world, in Japan, using my website in Japanese, and they send me this replay, and then I get it, and it's their environment, but I can go and console log in it. Nuts. Let me guess how that works. So you have the running browser and you have the backend talking to it. So when I add a line, is it just evaling the line in the running browser at that point in time?
Exactly.
Wow.
Like that is like that right there, the ability to run an eval over that network against a copy of the browser at a point in time is like the magic hammer that I can use to smash any problem. And so like the flagship feature of Replay is print statements. So I have code, I have recording. I didn't have console logs in the recording itself, but I can just go back, pick a line of code, see this line of code got hit 17 times. I add a print statement on that line, and I say, quote, the value of X is, quote, comma, X. And it is going to literally evaluate the expression and retrieve the value of whatever X is every single time the line of code ran. And that literally is all it's doing. We know the line of code got hit 17 times. We know the exact timestamps of every time that line got hit. And so we are just going to multiplex and run an eval at all 17 points in time and just eval X and we get back a description of whatever JavaScript variable it was at that point in time, and then we show those as entries in the message console.
That's so. Look, man, this podcast's about eliminating imposter syndrome, and mine was just slightly damaged because I can't believe I predicted that so easily. I thought it had to be more complex than that. Not to say it's simple, but like, wow, I'm pretty proud of myself for that. That is excellent. And the cool thing about this print statements after the fact or console logs after the fact is you can even do it in the Node modules, right? Because as part of this pre-processing step, Replay will not just get the source files, but also the dependencies. You can then go into Node.
So that there's actually a few different things that happen right there. So say the code for Redux Toolkit was in Node modules on your local machine or the CI build machine at the time that was built. What got deployed was a minified JavaScript bundle.
Yes.
Which actually bears no resemblance at all to the source file layout that was sitting on the machine at the time it got built. So Replay is a debugger, and like all JavaScript debuggers, we rely on source maps. So for those who aren't familiar with them, a source map is a big JSON file that says, here's the minified code, and like the minified bundle is probably like technically one line of code that's like 1 million characters long. And line 1, column 725 to 734 is the keyword function, and it maps to to-do list item.js line 37, etc. And so it actually literally contains the exact original source code of all the different files in there. And so it's reverse mapping from the minified bundled transformed code backwards to what the original source code looked like. And it's also saying that here is the name and the path of the original file. So what got served by your website was, app.js, possibly with like a hash in the file name.
Yeah.
But the source map is a sidecar file that then allows you to translate backwards from minified code to what the original code looked like. So it's the bundled minified code that executed in the browser. It's the bundled minified code that's executing at replay time. But we've got the source maps too, hopefully, assuming you built and deployed with source maps. And so we can go backwards from here's the minified code that ran to what the original source code looked like, and show you and let you debug the original code as a result.
Can I ask you a follow-up question about this? And there's no easy answer. The answer to this is it depends. But let's try and zero in on a rule of thumb. It always depends, but if you have to bias towards one way or another, which way would you bias? And the question is this: should developers ship bundles with source maps? And I've heard people go back and forth on this for a couple of reasons. One, if you're shipping something that's proprietary, like Amazon.com, and you don't want people unwrapping your minified bundles, then obviously don't. But also, if that makes debugging, especially if they're using Replay to debug something, super hard, because then how do you unravel that stuff without a source map? So I'm curious if you could speak to the in between here. Like, which one should we bias towards?
I would lean towards mostly yes. It is kind of, to some extent, it's a question of, how often are you going to be, in essence, trying to debug your website in prod. The big rule of thumb is all your code that's running on the client is effectively unsafe. Even if you're shipping just the minified bundle and you're not, doing source maps or anything, always is like people can prettify it and deobfuscate and, auto AI guess the file, the variable names and all this other stuff. At a minimum, they can inspect the control flow and see the API calls that you're making. Like anything that you're doing on the client can be figured out with enough time and effort. There's a little bit.
Well, you could also, sorry to interrupt. You could also just take minified code without source maps and paste them into something like ChatGPT or Claude 3 and boom. Okay.
There is a little bit of the security through obscurity bit where like they can figure it out, but I don't necessarily have to make their lives easier when someone's trying to reverse engineer things. But I would generally lean towards shipping source maps. Now, in Replay's case specifically, we do have the capability for teams to upload source maps separate from the recording being made. So, maybe you're not shipping source maps on the website, but you can, auto upload source maps to like a workspace or within Replay, so that when the recording gets made and it didn't have the source maps attached, we kind of match up the source maps on the fly within our own backend.
Okay. Thank you. That was a really good answer, and I appreciate that. Especially the point of like everything you run on the client's device is unsafe, whether or not you have source maps. I think that should lend itself to always ship source maps, which should be my suggestion and recommendation. Cool. Let's talk about the future of Replay. Specifically, what's next? I know that it's useful. It's proven value to me and some teams that I've worked with. I do know that also Replay has support for, and I did want to ask you about this, Replay has support for Node.js. So even for environments where there is no browser, I think Mateusz from the Stately team, formerly, gosh, I forget his name on GitHub.
Anderist.
Right. Yeah, is constantly doing things with Replay and TypeScript and Node.js. Does Replay support Node.js? And if yes, how can one start to use it? I assume there's no like record button on a terminal.
Right. So let me walk through the technical support matrix that we've got right now. So the replaying technology started within Firefox, and so for the first couple of years, the only recording browser we had was Firefox, and that worked on Mac and Linux, and it mostly worked on Windows. Naturally, the Windows version has had more issues and has been less stable. And as the only Windows user within the Replay team, I've sort of been I've had my issues with trying to make recordings with Replay Firefox on Windows. Like sometimes they just break. We are in the process of switching over to making the Replay Chrome fork our primary recording browser. It's been a very long ongoing process. Frankly, it's been a lot more long and ongoing than we wanted it to be. It's definitely not complete yet, but we have made a lot of very good progress. And being straight up front here, right now we consider the Firefox fork legacy. We are not doing any development work on it. We are not attempting to fix more issues. All the development resources are going into the Chromium work. We are unfortunately at a very awkward transition point right now. So where things stand are, Replay Firefox for Mac and Linux works. Replay Firefox for Windows is there, but it's still kind of beta alpha-ish and is more prone to issues. Replay Chrome for Linux is rock solid with the recording and the replaying aspects. Replay Chrome for Mac exists. It's still kind of alpha, maybe not quite beta level. I think there are some issues with the recording stuff, but they're working on driving the stability into a better place. Replay Chrome for Windows technically exists, but not particularly usable at this point. The biggest pieces we're missing beyond the platform recording stability support, Replay Firefox has that recording button that you mentioned. So an individual developer can download the browser locally, open it up, go to a website, manually first click the login button, and the authentication stuff happens so that our backend knows who you are, so that when you click the record button, the recorded data is uploaded to the correct account. Replay Chrome doesn't have either of those yet. It doesn't have the authentication infrastructure, and it doesn't have the login button. And so right now, Replay Chrome works great for the CI use case, and especially like the recording end-to-end tests. So you can configure your Playwright or Cypress suite to run the tests with our recording browser as the browser, and then we automatically make replays of every test that you executed. But that does mean it doesn't really work well for the I want to make a recording of one website for me as an individual developer use case. You can do it, but it takes a little more work. So we do have a CLI package at replay.io/replay that does let you download the recording browser to your machine. If you open up that browser kind of like by yourself, it just automatically starts recording literally every tab you open up the instant you open up the tab, and it stops recording when you close the tab. Like there's no start stop button. And the recordings are by default saved locally to a temp folder on your machine. So you then have to use the CLI tool with your API token to do the upload. So you can do it. You can make the recordings manually, one at a time, but it's a little more involved process. We want to get to the point where that login and record button is in the toolbar. We've made some progress on it, but we kind of had to pause the work to deal with some more like stability and some of our own internal CI type issues. But getting that finished is a very high priority for the next couple months. So awesome. For Node specifically, we also have a very alpha level fork of Node 16 for Linux. We are not we are not putting any development resources into it right now. The goal, like all the focus is on getting Chrome done. Having said that, the Node fork does actually work. I've used it to record jest and vtest tests. As we pointed out, Anderist, who frequently submits PRs to the TypeScript compiler, will record his local build of TypeScript, record the compiler and then go debug the compiler. We actually recorded a video a couple weeks ago. There's a group called Michigan TypeScript, which if you haven't heard of them, Tejas, you would appreciate them. They do like deep dive things on TypeScript.
Oh, nice.
And like they are literally targeting like the advanced TypeScript user as their group. So like Lenz and I went on a couple months ago and did a talk about Redux Toolkit internals. And then Anderist and I did a recording with Dimitri from Michigan TypeScript where I talked about how replay works kind of big picture. And then Anderist literally showed debugging the internals of the TypeScript compiler with replay. So that video is up. So the Node fork exists. It's not being worked on actively right now, but it does work well enough to actually use it.
Awesome. I did see the Michigan video with you and Lenz, but I didn't see the one with you and Anderist, and I need to go see that because like I have so many questions. Like how, if I record a replay with the Node fork, what do I see? Do I see the terminal? What's the visual side of it? You don't have a browser that can just yield a JPEG.
There is no visual, so we actually just hide the video panel in the debugging UI. There's still console messages, there's still source files, so the rest of the debugging aspect is still the same.
That is so cool. Okay, let's wrap up. I have one final question. It's a bit of a Twilight Zone question that's maybe silly, but it's been on my mind this entire time, and I want to ask it. You mentioned it. So replay listens to the browser. I'm talking about the recorder, either the browser or the Cypress, the browsers, all of them. So the runtime listens to OS level syscalls that call into kernel space for network packets and things like that. I made an episode on this podcast that's in season 1 about event sourcing, and this is exactly what you're doing. You're sourcing events from the kernel. Since you have all these events stored in a recording, then it's within the realm of possibility to do some Doctor Strange magic and swap out events, and then see how they lead to different outcomes, and lead to and not just lead to different outcomes, but track the process over the time of the recording. Is that possible? Is that a potential future feature that y'all see the potential for, or is that just we don't talk about that yet?
That's a question that comes up quite a bit, and that's where things get very complicated. So let's say that you're debugging an issue and you find the line of code that was the problem, and you make like
Yes.
maybe even like a 1-character fix to the
Yes.
original source code. What would be involved in trying to rerun the entire replay, but with that one tiny tweak to the line of code? And it is really, really complicated. So you would need to rebuild your app, which is going to generate a whole new JavaScript bundle that in the end might be like 1 character different. You know, maybe you typoed a variable name or something. You know, perhaps the build results in a different file name, you know, a different hash in the JS bundle name or something, which means that, you know, conceptually the browser is making a request to a different URL, and then, you know, like you would conceptually need to go in and replace, like, take the recorded data, replace the fact that a get request was made for app.abcd.js, and instead make a request for app.abce, you know, different hash.js, which is going to have a very slightly different content. And then, assuming we somehow swapped that out in the recorded instruction stream, when we do the replaying, the sequence of behavior is going to end up being a little bit different. And right now, we keep enough track of what happened during recording time that we kind of compare it with what is happening at replaying time. And if it looks like they're diverging, we assume that our browser replaying process is broken and just kill it. So the short answer is I could hypothetically imagine it being possible someday, maybe, but there's an awful lot of work that would need to be done to make something like that possible.
Yeah, but I'm glad you see the potential, because it's like simulating the butterfly effect, where you can even trial a fix. So you get a replay that contains a bug, and you can fix it in the replay before like allocating more engineering resources and doing like GitHub pushes and pull requests and reviews and all of that, just right there. So I love that this is hypothetically, possibly, maybe, and I hope for a future one day where I get to play with that. That sounds so cool.
I know you said that was the last question. I actually have one other topic I would like to hit on for a few minutes.
Absolutely.
So
for sure.
I said earlier that our backend offers a time traveling API as a service. And what we've built with it so far is a debugger. Now, it's a debugger that has all the time traveling stuff built in, but I've said from the beginning that we are barely scratching the surface of what is possible when you have that whole API at your fingertips. And so last year, I got to go off and start exploring building some new features that actually make use of that API in relatively new and innovative ways. And Tejas, I know you're somewhat familiar with this, but I'll hit some of the highlights, and then I'll talk about a little bit about where we're going with some of these things.
Just, before you do that, can we clarify the API? This is an HTTP API.
Okay, cool. Sort of. It's actually technically over WebSocket, but close enough. I mean, you could think of it as being over HTTP. So and the thing is, like, anyone could do this. The API is public. It's documented. We have a package that wraps the API. So like you could actually just write a Node script that talks to our backend, creates a session for a given recording, assuming you have the permission for it or it's public, and then start saying, give me the list of the source files, or, pause a browser at this point in time. We actually have a repo with some examples of some different things we've done. And like literally anyone could start writing a script right now. So the biggest thing that I've built is an additional set of data extraction pieces on the back end that we call routines. So we've got what we call the basic data extraction step. Like that's all the data that is essentially permanent and fixed, and we always want to extract it ahead of time. But once we've got the API available, you can use that to inspect and manipulate and understand what happened at runtime in the recording any way you want to, programmatically. So,
but what do you mean by manipulate? Does that mean this API is not read-only, but I can actually go in and change stuff?
I said earlier that eval is the magic hammer that you can use to solve any problem, and that includes effectively mutating the contents of the browser. So when we have a paused browser instance, I can eval X, and it will return me the contents of the variable named X at that point in time. What happens if I eval, like, obj.x equals 1, 2, 3? I just mutated the contents of the JavaScript environment in that paused browser at that point in time. Now, we actually treat each paused browser copy as kind of like a unique mutable scratch pad, and you can have many different copies of the browser paused at the same instant in time. And if I mutate a variable in paused instance 1, it does not affect the copy of the JavaScript environment in paused browser 2. So just many copies of the program all paused at the same point in time. But what that means is that I can inject JavaScript and execute it, and I can send multiple commands in a row, and I can build up some information in the environment, and then I can do fun things with it. So specifically, there's 3 different routines that I built over the last year to extract additional data. One of them is our React DevTools support for Chrome. When I joined Replay, we already had support for the React DevTools with Firefox recordings. The way we did that was we actually copy-pasted the entire React DevTools extension JavaScript bundle into our fork of Firefox. It was built into the browser, and we auto-loaded that inside every page you browse to, in the same way the extension would auto-load the JavaScript. So when you made the recording, React in the application page thought the extension was installed, and it would report every time it did a render. And then we kind of hijacked the data, and instead of like passing it to the extension UI, we would save a copy of the data in our back end. So when you open up the recording to debug it, we would fetch all the commit descriptions, and it's the same data format, and then we could pass it to the UI layer, same tree view component and everything, and we could display the tree. But that added some extra overhead performance-wise to the recording process, and it kind of like locked us to the exact version of the extension code that was in the page at the time of recording, and that has kind of changed over time. So for our Chrome fork, we wanted to support it a different way. Well, we've got an API that lets us talk to the page, and we can inject JavaScript. So what I figured out was I can take that same React DevTools extension bundle, dynamically inject like 150 kilobytes of Minified bundle into the paused browser. It's now just like the extension code exists in the page, and I can ask it, give me the description of the component tree at this point in time, or tell me what the props and the state are for this component by its ID. And this also required making some tweaks to our Chrome fork, because we need to know the timestamps of every time React rendered. So I said earlier, like we've got both custom C++ and custom JavaScript code in our fork. So I actually went into the custom JavaScript portion, and I created like a little fake version of the global variables that the React DevTools extension installs, so that, again, React in the page thinks it's talking to the extension, but it's actually my little bit of JavaScript that just saves timestamps. So React rendered. And then later on, I can query for the list of timestamps, inject the DevTools code into the timestamp pause browser, and then ask it describe the component tree. I actually did a talk about this at React Advanced last fall, and I've actually got a lot of the code for that copy pasted into an example repo if people want to look at it. So I did the React DevTools work. I did something similar for Redux, where we track the timestamps of the Redux actions, and then we can go in and extract the action, the state, and the diff. And then I did the feature that you have seen, which is called Jump to Code. So when I joined, we already had a sidebar that showed the list of all the clicks and the key presses that happened during the recording. And we knew the timestamps of those, but there was no association with what code might have run in response to that user interaction. And so I was able to go in and figure out how to associate the fact that the event happened with the code that ran. And this required both using our backend API and knowing a fair amount of React's internals. So it turns out that every time React renders a DOM node, a div, a button, whatever, it actually attaches a copy of the props for the DOM node to the DOM node JavaScript object. Like every DOM node is a JavaScript object. It's got functions and fields and methods. And when you do document.getElementById or query selector, it returns a JavaScript object for the DOM node. It's a JavaScript object. You can just randomly mutate fields or attach things to it. And so React attaches a copy of the props as a super secret field name on that JavaScript object. You can see it.
I didn't know that.
You can see it if you click on an element in just random browser DevTools and you go to the DOM attributes view of the DOM node. So what I figured out was React attaches that to the DOM node. I know that an event happened, like a click, and that some JavaScript code ran in response. We know that in JavaScript, one of the arguments to an event callback is the event object, which has an event.target field that is the DOM node. So I start from the event, I go into the JavaScript callback, I find the event object, I look at event.target, there's my DOM node, I look at event.target bracket super secret field name, and I look to see if there's props. And if I know that this was a click event, then there's probably a props.onClick attached to the element. Or if not that element, maybe one of its parents. And so from there, I get a reference to the function instance. Using our protocol, I can find out that, okay, this is a Minified function that was in app.js line 1 column 700,000, but it's actually handle click in to-do list item.ts line 37. And then I can check, okay, how many times did that function get called? And is one of them right after this click event? And if so, that probably ran in response to the click. And now I've made the association between the click event and the code that ran. And so from our UI, when you hover over the little list item that says click happened 17 seconds in, we can now show a little jump button that takes you to the line of code and pauses at that time. So we're starting to use the API to let us introspect and do new and interesting things. So building on that helps at the debugging use case level. I'm an individual developer. I've opened up a recording. I'm trying to understand what happened in that recording, and I want to see the component tree or the Redux actions or figure out what handled this click. But if you can do programmatic introspection of one recording, you can do programmatic introspection of many recordings. So we've built our test suites feature that lets you debug Playwright and Cypress tests as they ran in CI. And we've got a dashboard that, records all the test executions and shows you, for this PR, 100 tests ran, 3 tests failed. And here's all 100 recordings, but especially here's the recordings for the 3 tests that failed. You can pop them up and open them. Well, if your team pushed 20 PRs in the last week, maybe those failing tests actually passed on 18 or 19 of the test runs, and they only failed in 1 or 2 of the test runs. So we've actually got like 20 copies of the same test running. Most of the code for that is going to be pretty much identical unless people have been touching those files. So we've actually got a whole bunch of examples of good test runs versus a failed test run. And we've got enough instrumentation that we can actually kind of start to track the flow of execution in the JavaScript and figure out where the 2 tests, one passing and one failing, diverged from each other. So we are actually working on a prototype feature right now that we call root cause analysis. So if I have, a whole bunch of test runs, some passed, some failed, can we automatically figure out where things went off the rails? Was it that, a network request came back too slow, or that there was, a DOM element was on the screen, but it was hidden by something else, or a React rendered a different number of times. And we're doing it by programmatically comparing the sequence of execution between a bunch of past test runs and 1 or more failed test runs. And it's still at the internal prototype level, but from what I've seen, it's actually pretty much working at this point.
Wow. When can I get access to that feature? Is there a flag? Can we turn it on for my account?
I possibly talk to Jason or Gerald. I think they might be able to get that worked out. The one other thing that we've talked about that we're hoping to get to at some point in the next couple months, we actually have a first working example of some React time travel capabilities. So the React DevTools extension will show you a little bit of, this re-render was caused by hooks changing in this component, but it doesn't give you a lot of details. When Brian Vaughn rewrote our React panel, he actually does have some of that information captured, and he can actually show you which hooks changed, and I believe what the previous hook or prop value was versus the current one. So we've got that in Replay's UI right now. We've also talked about being able to show things like, what is the difference in the component tree between different points in time, or if you are paused inside of a React component while it's rendering, what is the parent tree, or kind of figuring out what caused the render. We don't have those yet. Those are features we want to try to build, but they are more examples of things we could do with the time traveling backend API, which I'm very excited about.
Which is also, as I understand, open to anybody to use however they want for whatever use case they want, provided they can authenticate.
Like I said,
awesome.
we've got I think it's replay.io/protocol examples repo, which has a few different Node scripts, and I've copy pasted the backend routines as examples of what you can do. So literally anybody could start writing useful things with the protocol if they want to.
That is so cool. Yeah, I'll be sure to look into that myself. I didn't know that was API driven. I thought this was just inside the debugger, but now that I know it, it's somewhat decentralized. I also want to look at things I can build, because y'all are handling the debugger specific use case for this, but there's an enormous number of other use cases that I'm sure the vast majority of us can think of. So I'm really excited about that. I will put those links in the show notes as well. And if you're listening to this at whenever this episode is live and it's not in the show notes, that means I forgot, because I do all of this. I don't have a producer or anything. And so if you let me know that's missing from the show notes, I will add it. With that, listen, Mark, I know it's not easy to set aside 2 hours at the beginning of your day and come chat with me. Especially at this level of depth. I don't know how many coffees in you are, but it seems like it worked. And I just want to take a moment and appreciate your excellence, your brilliance, your in-depth knowledge of syscalls and OS level and backend and front end. On behalf of me and all the listeners, thank you so much for making time to come and share all this with us on the Contagious Code podcast.
Thank you. It's been a lot of fun. I've actually spent the last 3 months on our back-end team rather than our front-end team. So some of that information is still relatively new to me, but it's given me a better appreciation of what's going on at the different layers of our system.
Awesome. Well, thank you again for coming on. Thank you for joining my discussion with Mark Erikson. I hope you're as moved by it as I was. I hope you're as impressed in the engineering that goes into a product like Replay that was once a fork of Firefox and is now the fork of Chrome, and also of Chromium, I should say, and also how they really reverse engineer so that we don't have to, so that we get the best debugging experience. I hope you were thrilled to learn that Firefox DevTools is a React app, among a number of other things we uncovered in this episode. If you're learning from and or enjoying this content, please, if you're watching on YouTube, subscribe to the channel and leave a thumbs up. If you're listening on Apple and or Spotify, if you could leave up to a 5-star review, that'd be super helpful. Just glean some signal from the noise. It would help us understand, like, is this worth doing? Should we continue? Etc. Thanks again to all of the sponsors. There's links in the show notes. Thank you for being a part of this, and thank you for your interest in engineering.